Alright, so I think this is recording. Let's take a look at these problems for a review of polynomial functions. So they give us a polynomial function that's in factored form here. To determine the leading coefficient, we'll take the coefficient in front of the variable of each factor and multiply them together. So the leading coefficient I get is negative 12. For the degree, we'll take, since it's in factored form, and by properties of exponents, when you multiply and you have the same base, you add the exponents. So since this is multiplication in this factored form, we'll add each factor's contribution towards the degree. So here, this factor is contributing 1. This factor is 2 times 1 is contributing 2, and this is contributing 1, so the degree of this is 4. Here in standard form, we look to find the largest exponent on a variable, so we're interested in this term, and the leading coefficient then is negative 1/7. And the degree is the largest exponent, 9. This graph is not smooth because smooth means that it has no sharp corners, and here this is a sharp corner. The graph is continuous because you can sketch the whole graph without ever lifting your pencil up off of the paper. This could not be a polynomial, because polynomial functions are smooth and continuous, and they also have an end behavior that falls into one of 4 categories, either up and up, down and down, up and down, or down and up. So you'll never have a horizontal asymptote. The end behavior when you're far away from the origin will always be heading towards positive or negative infinity. This graph is smooth. This graph is continuous. You can sketch it without ever lifting your pencil off the paper. It has an end behavior of down and down. So yes, I believe that this could be the graph of a polynomial function. The end behavior here, to the left it's going up, so as x is approaching negative infinity on the left, the y values are approaching positive infinity. Over here, as you move to the right away from the origin, as x is getting larger, y is heading down towards negative infinity. Here we want to answer in the same way, but only using the degree of the polynomial and whether the leading coefficient is positive or negative. When we look at the exponents here, the term with the biggest exponent here is 8. So our degree is an even number, which means that when we come in here to write our infinity symbols, they're going to agree in sign. Either they're both going to be positive or they're both going to be negative. Since the leading coefficient is negative 7/2, and that's a negative number, then these are both going towards negative infinity. Since they were even, they were the same sign, and since it was negative, the leading coefficient, then they're both negative. Here let's determine the degree. This factor is contributing 1. This factor is contributing 1. This factor is contributing 2. So the degree of this is 4. That's an even number. They are going to agree in sign, either both being positive or both being negative. Let's determine the leading coefficient. If we look at the coefficient in each factor, negative 5, positive 1, positive 1 squared, which is still 1, So the leading coefficient is negative, which means that both of these are negative. To find the x-intercepts, we let y equal 0, and we solve this equation in factored form. So now each individual factor is set equal to 0 and solved. So I've got 3x plus 1. If that equals 0, then 2 steps, subtracting 1 and then dividing by 3. If 5x plus 3 is equal to 0, in 2 steps, subtract 3 and divide by 5. If x plus 1 equals 0, it's just 1 step, subtract 1 from each side. And if 2 minus 3x equals 0, it's 2 steps. Alright, so those are the 4 x-intercepts. Since this is of degree 4, there's no more. We have found all of them. For the y-intercept, we let x be 0. So in this first factor, we just have 1. In the second factor, we have 3. Because the x's are 0, right? The x's, and then this is 2. So this y-intercept is 6. Same idea. For the x-intercepts, you let y equal 0. This is called quadratic form. The degree of this middle term is half of the degree of the leading term. So we can factor this to x minus 4, x minus 9. Oops. Sorry, x squared minus 4x squared minus 9, which factors to x plus 2 times x minus 2, x plus 3 times x minus 3. If you set the first factor equal to 0, you get a negative 2, a positive 2, and here if you set this equal to 0, a negative 3, set this equal to 0, and a positive 3. So those are the 4 x-intercepts, and it was of degree 4, so you can have no more than 4. To find the y-intercept, you let x equal 0, so the y-intercept is 36. Write a polynomial function that has these zeros. So x equals 0 just means that it has a factor of x. In factored form, you change the sign. So if x equals negative 5 is the 0, also called the x-intercept. In factored form, it's x plus 5. When it's 3/4, the denominator will be the coefficient, and it will be opposite in sign just as the others. So they don't give me any other information about enough to determine what the degree is, what the end behavior is, or what the leading coefficient is. So I'm just going to choose 1 as the leading coefficient. Now here they want me to write the equation. I'll use the y-intercept to determine the leading coefficient in just a second. First, I'll use the x-intercepts in factored form. The negative 5 is x plus 5. Since it's crossing the x-axis, it'll have an odd degree, so I'll just pick 1. Here, negative 2, I'll write it as positive 2. Since it's a touch and turn, it'll have an even multiplicity, so I'll just use 2. Here at 3, change the sign in factored form. It's another touch and turn, so I have this. So the coordinates of this, y-intercept are 0, 5. So when x is 0, the output of this function is 5. So when x is 0, I just have 5 times 2 squared times negative 3 squared. And the output of this function, the left-hand side, when you evaluate p at 0, all of this arithmetic should equal 5. So we have 5 times 4 is 20, times 9 is 180, and divide both sides by 180. 5 over 180 reduces to 1 over 36. So that means that our final answer, that the leading coefficient is positive 1 over 36. We knew since it was going up to the right that it would have a positive leading coefficient. And since the degree, since the other side is going in opposite directions, the degree must be odd. So if we check that, we've got 1 plus 2, which is 5, and 5 is odd. So here's our answer for number 11. If x plus 5 is a factor, when we do our synthetic division, we'll get a 0 remainder. If in factored form, the 0, you change the sign. You'll always check to see if this is in standard form with no missing terms, and if there's no greatest common factor. 2 and 5 don't have any common factors, so I know that there's no common factor to all of them if there's no common factor between the first two. So if this is in fact a zero of this function, a factor, if x plus 5 is a factor, then I'm expecting a 0 right there. So let's see if that happens. If it doesn't, then either I've done something wrong or the problem is stated wrong. It has a typo. So we have shown now that this is a factor. We want to use the results to find all of the factors. It doesn't say that we have to solve it. So for this degree 3, I have a factor of x plus 5, and now this other factor is 2x squared minus 15x plus 7. Now this may or may not factor. Let's see if it does. Two x times x is 2x squared. With this being positive and the middle term being negative, both of these terms have to be negative, and 2 times the negative 7 is negative 14, minus another 1 is negative 15. So now we have found all of the factors. We don't have to find the zeros. It said to find the factors. To determine this, we could plug in negative 4 into this function, negative 4 to the 6th power plus 7 times negative 4 to the 5th. But you can see that negative 4 to the 6th power is, I don't know off the top of my head what that is, but if I do synthetic division, I'm not expecting this time, it could have a remainder of 0, but it's not saying that this is an x-intercept. It's not saying that this is a 0 of the function. Could be, but I'm not going to be surprised if my y-intercept is different than 0 here. So pull that down. when you're using the calculator, make sure that you key in the right values, but that's not going to help. Did I do this right? Remember that answer. 6, 5, 4, 3, 2, 1 constant. No common factors. 1, 7, 7, negative 12, negative 20, positive 31. First number comes down. It gets multiplied by that. 7 minus 4 is 3. Negative 4 times 3 is negative 12. That's negative 28. Negative times negative is positive. 32 carried 8 and 3, 11. Yep. 29 is, I thought I did that on the calculator. Yeah, okay. I just simply don't remember it. Times negative 4. So we can check our answer by plugging in negative 4 into this. So I'm going to go ahead and do that. And we could have done this right off the bat, but to the 6th, to the 5th, to the 4th, to the 3rd, So we're getting the same value. So whether you plug it in or do the synthetic division, you get the same answer. So there's our answer, that f at negative 4 is equal to negative 8,337. List all the possibilities. Well, the constant term, let's list it. Factors of 4. Don't forget that it's plus or minus. The factors of the leading coefficient. We create a list that we're not saying that these are the x-intercepts, but we are saying that if this graph does have x-intercepts, and if those x-intercepts are rational numbers, that they'll have to be in this list. So don't forget the plus or minus. And each of these is divided by 1. So I've got 1, 2, 4, and now each one of these is divided by 5. 1/5, 2/5, 4/5. And there's our answer. It's not asking us to check this list. It's just saying to list the possible rational zeros. So those are the possible rational zeros. Now here it's actually wanting us to find the zeros. So let's set the output of the function equal to 0 and factor this completely. This factors to 2x plus 3 times 2x minus 3. This factors to 2x minus 3 and x plus 2, because that'll give me a 4x minus 3x, which is 1x. I have two factors of x plus 2, so that'll have a multiplicity of 2. I have two factors of 2x minus 3. I have a single factor of 2x plus 3. So 1 plus 2 plus 2 is 5. 2 plus 2 plus 1 is 5. So we found all of the x-intercepts. If we set each of these factors equal to 0 and solve, we've got negative 2. If you add 3 and divide by 2, if you subtract 3 and divide by 2. So we've got these three zeros, and they want us to know how does it intersect the x-axis. So the negative 2, because it has an even multiplicity right here, it'll do a touch and turn. X equals 3 halves also has a multiplicity of 2 that's even, so that's a touch and turn as well. And at negative 3 halves, it's a multiplicity of 1, that's odd, so it's just crossing the x-axis, not doing a touch and turn. So here we have a degree 3. We don't have an x method to factor this. We can't factor this in a table by grouping or anything. So let's list the factors of our constant term. This is our possible numerators, 1, 3, and 9. The bleeding coefficient, because this was in standard form with no greatest common factors. I should have checked that first, I guess. I did in my head, but I didn't say it out loud, I don't think. So the list, if this is crossing the x-axis at a rational number, it'll be either 1, 3, or 9. So we need to do synthetic division or plug in the numbers to see if we get a 0. Since all these are positive terms, positive numbers are not going to do it. So let's try some negative numbers. So we have found one right off the bat. So that means this function g of x can be factored, and that we have a factor of x plus 1 because you changed the sign in factored form. And now this 169 is 1x squared plus 6x plus 9. Set this equal to 0. Solve this equation, x plus 1. This is a perfect square. It factors to x plus 3 squared. So we've got zeros, which are also called roots and also referred to as x-intercepts. We have two of them, but one of them has a multiplicity of 2. 1 plus 2 is 3. The original function was of degree 3, so we're not missing any factors, or excuse me, any zeros. So at negative 1, the multiplicity is 1. That's odd, so it's going to do a cross with respect to the x-axis. And negative 3 is also a 0. Its multiplicity is 2, which is an even number, so it's doing a touch and turn. We look here and we see that all of these numbers are even, and they all have a x to the third in common. So we're going to factor out that greatest common factor of 2x to the third, which leaves us 2x squared plus 5x minus 12. That may or may not factor. With this being negative and this being positive, we have a positive factor and a negative factor. A difference of 1 here. So if I try different combinations of 2 and 6, I'd have either 4 and 6 or 12 and 2. That's not going to have add up to a positive 5. If I try 4 and 3, I'll have, here it is. If I go, that'll give me 8, and then minus 3 would give me 5. So here's how this factors. You can do the X method on that if you can't see the possible combinations. We have x equals 0. That has a multiplicity of 3. 3 is an odd number, so it's crossing the x-axis. And here, if we add 3 and divide by 2, its multiplicity is 1, so that's also a cross. And then finally, we've got negative 4 plus positive 4 gives us 0. And that's also a cross. So that's it. Hope that helps. Talk to you later.